This is a lesson on factoring, and I've broken factoring up into two different lessons, two parts, because in this lesson I'll talk about greatest common factor, the box method, factor by grouping, factoring for terms, all that stuff, and then in the next one we'll do some different factoring techniques. So factoring is important because you're going to keep using it throughout algebra, calculus, and other branches of mathematics. It is used to help us find roots or solutions of functions, which is the place where a graph crosses the x-axis. So that's kind of where this is leading. We won't be finding the roots in this lesson, but you will be learning how to factor to help you do that in later lessons. So what even is a factor? I'm talking about factoring and factors. What is a factor? A factor is a quantity multiplied to produce a given value. Some examples of factors, it could be kind of blatant like this. 2 times x is 2x, so the two factors of 2x are 2 and x. Or 6, your factors are kind of hidden. Or 8, it breaks up into these two factors. So a factor is something that multiplies. And then in this lesson I mentioned we're going to be talking about greatest common factor. So the greatest common factor between two or more terms is kind of in its name. It is the largest factor that two or more terms have in common. So it's literally the largest factor that goes into both terms. Let's look at an example. There's several ways you can find a greatest common factor. Obviously, you can kind of look at it. If you're good with factors, you can see, between 15 and 36, what is the largest number that goes into both 15 and 36. You could even make a table if you wanted to, list out some factors of both, and find the largest common factor. But for the sake of this lesson, I'm going to use their prime factorization. And if you remember prime factorization from some previous classes you might have taken, you break it up into its prime factors. So you stop when you reach prime numbers. I'm going to write those out. 15 is 3 times 5. 36, I'm going to keep it expanded for the sake of this lesson. And then you circle what they have in common. So you can see it's the same as we got over here. You can use either method. It really doesn't matter. I'm just using the method I've done here for the sake of the lesson. So their GCF, greatest common factor, is 3. That is the largest number that both numbers divide by. Let's look at 16x squared and 14x to the 7th. 16x squared, if I did the prime factorization, would be 2 times 2 times 2 times 2, and then x squared. 14x to the 7th would be 2 times 7, and then 1, 2, 3, 4, 5, 6, 7 by definition of an exponent. And they share a 2. They also share an x and another x. So you might think, don't be confused with greatest common factor, you're looking for the greatest number. That's not necessarily the case. You're looking for the factors that they have in common. So it's actually the smaller number. And then I would write my answer, the GCF is 2, x times x is x squared. So that is the largest factor that goes into both terms. We're going to be using that for this next example to factor basically any polynomial. Anytime you factor a polynomial of any size, you have to look for a greatest common factor first. So we have this binomial. When I say binomial, it's because it has 1, 2 terms separated by a minus. And we're wanting to factor it. So factor means I want to break it up. I want to break this up so I can have a better picture of maybe what the graph looks like or where those roots are. So we're not going to actually find the roots, but we are going to find the factors. And to do that, you're looking to see if they have anything in common, if these two terms share anything. So let's look at the prime factorization of 15x squared and negative 35x. That's going to be 3 times 5 times x times x. I'm going to have a negative 1 out here since it is negative, times 5 times 7 times x. Okay, so let's look to see what they share. They share a 5 and an x. I'm going to write that out here. That's what they have in common. And then I'm going to write these parentheses. So the purpose of these parentheses is that I'm going to write what's left over inside. So what do I mean by what's left over? I've taken out 5x from both terms. So there's stuff left over here that I can't just ignore. When I took 5x out of 15x squared, I'm left with 3x. So I'm going to write that here. And when I took 5x out of negative 35x, I'm left with negative 1 times 7. So my factored form looks like this, which you might be thinking, that doesn't look like what we started with. And you're right, it doesn't, but it is the same thing. We've just broken it up into two factors. Let's check our answer to just kind of make sure that we're on the right track. I do know, using the distributive method, that I can multiply this back out. And when I multiply it back out, I should end up with my original binomial. If I don't, then something's wrong. So, whoops, took you on a little ride. Let's take this 5x and multiply it by 3x. And 5x multiplied by negative 7. Does this equal my original binomial? Yes, it does. So that is factored form. If I had asked you to solve, you would have to keep going. But in this case, I just asked to factor, so that's done. Excuse me. That's factored form. I have 5x is a factor, and 3x minus 7 is also a factor. Let's go to the next page. This is a 2-page lesson, so it's kind of short. Now I have a trinomial because it has 3 terms. And you can do the prime factorization for these 3 terms, which is fine. I'm going to show you the shortcut just to kind of save you a little time if you're doing homework or a test and you want to do it a little bit faster than writing it all out. So let's think common sense. Do 48, 12, and 16 all divide by a number? Yes, they all divide by 2, right? Yes, they do all divide by 2, but that's not the largest number. So let's go further. What's another number that they might all divide by? Not 3. Ooh, what about 4? Do they all divide by 4? Yes, they do. What about 8? Do they all divide by 8? No, they don't. So 4 it is. I'm going to pull a 4 out here. Now, do they all share anything else? Do you see anything else they might have in common? Yes, indeed. They all have a variable. They all have x. What is the largest x they have in common? So if you're having trouble seeing that, you could expand these out. And what they have in common is only 1x. So we can only pull out one of them. And then what you're going to write as your leftovers goes in your parentheses. And we're focusing on this first term. 48 divided by 4 is 12. And I took out an x, so I'm left with x squared. Positive 12 divided by 4 is 3. And then I took out an x, so I'm left with x. Negative 16 divided by 4 is negative 4. And I took out an x, so that's it. I'm left with 4. And this is factored form. Yay! At this point, in later lessons, you would need to check and make sure this doesn't factor. And I wrote these notes, and I know it doesn't factor, so I'm going to tell you I did that on purpose because you don't know how to do that yet. So later that might be factorable. In this lesson, it is not. That's done. This is prime. This is factored form, and we're good. So my two factors are 4x and this trinomial. So that's kind of the short way. If you had wanted to keep doing the prime factorization, then you could definitely do that. For the sake of the length of the video, I'm not going to, but it's absolutely an option if you prefer it. So when a polynomial, actually just mentioned this, when a polynomial is not factorable, like I was talking about here, spoiler alert, it's not factorable, we call it prime. Prime means, if you think about a prime number, prime means it does not divide by anything except 1. So if we look at this next example, 3x plus 5, and we try to find a number that 3 and 5 both divide by, well, 3 and 5 are prime as it is, so they're not going to have anything in common because they don't divide by anything except for 1 in itself. So it wouldn't really make sense to write this. Well, it will later in the lesson, but for the sake of this problem, that doesn't really help us. So we would call this prime. It is totally factored. It's totally broken down. It cannot be broken down anymore. It is donezo, and that is just your answer. It is what it is. So we're going to use all these tools to help us with this next concept, factoring with 4 terms. So with any polynomial, your first step should always be to look for a greatest common factor. Always, always, always. If there is not a greatest common factor, then go on to your next strategy. If there is a greatest common factor, pull it out and then keep going. But if there's not, then move on to the next step. So this first example, I have a 4-term polynomial. Your first step is to see if all terms divide by the same number. And it's almost a 3, but 4 doesn't divide by 3. And they almost all have A's, but 3 doesn't. So there is no greatest common factor. In this case, when there are 4 terms with no greatest common factor, you can break it up to factor by grouping. So let's say I break this up into smaller pieces of 2 binomials. And let's just focus on one binomial at a time. So let's focus on this one. Are 12 and 9 both divisible by anything? They are both divisible by 3. They also both have an a squared. Now remember, I didn't pull out a to the third because they don't both have a to the third, but they do both have a squared. And then you're left with 4a minus 3. And I got that because I did 12 divided by 3 was 4. I took out 1a, so I'm, 2 a's, so I'm left with an a. Negative 9 divided by 3 is negative 3. And I took out both a's, so there's no a. Okay, now let's focus on the second binomial. Do 4a and negative 3 have anything in common that they can divide by? No. So in this case, we are going to pull out a 1. And since we didn't technically pull anything out except for 1, you just write what's left over. Now, we are still left with 2 binomials. Do you see anything in the binomials that is repeated, that is the same? You should, right here. The 2 binomials are factored, and in the 2 factored binomials, they share a factor. Lots of factors here. So let's pull that out front. And if we pull that out, you write what's left over. Whoops. And dun, 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 that's factored. In future lessons, you would check to make sure that this does not factor, and I will tell you it does not, so it's done. So that was really cool, and I really love factor by grouping, but what I love more than factor by grouping is the box method. Yay, the box method. I really like the box method because it's just more organized. It's not necessarily different, like you're not doing any different process. It just kind of organizes it in a nice, neat little package. So sometimes with grouping, you can get lost with the numbers and the signs and stuff. So I'm going to draw a 4 square box here, kind of like a Punnett square, a lot like a Punnett square. And inside the box, I'm going to write my 4 terms with their signs. And what this box does is it sets up groups. That's a group, that's a group, that's a group, that's a group. So we're still technically factoring by grouping. I've just put my groups in a box. And I'm going to focus on a group at a time. So let's look here. Are 12 and 4 both divisible by anything? They're both divisible by 4. They also both share an a. And then this column, you can go a different order. You can go here next if you want. This is just kind of my method. I like to go this order. 9 and 3 are both divisible by 3. They do not share an a, but you might also say, there's a negative there. Should you pull out a negative? And the answer is yes. If the first number you look at is negative, pull out that negative. Now let's go side to side with the rows. 12 and 9 are both divisible by 3. They also both share a squared. You might start to kind of recognize these numbers from the previous method by grouping. And am I supposed to pull out a negative with this row? No, because this does not have a negative. When the first term has a negative, then you'll go ahead and pull that out. So let's take a guess here. Am I going to take out a negative? No, I am not, since this is positive. Do these terms have anything in common? No, they do not. So I'm going to put a 1 there as a placeholder. You can write positive if you want to. I usually don't, but it doesn't matter. So these green numbers out here are your factors. Isn't that so nice? And it doesn't matter the order that you write them because we have the commutative property. So if you had wanted to, you could write it this way. As long as this is a factor and this is a factor, then it doesn't matter the order. So that's both methods. You can use grouping or the box method. I do not care what you use as long as it is helpful to you. Whatever way is the most beneficial for your learning is what I want you to use. I will typically use this method just because I like it better. I think it's prettier. So let's use it on this last example. First of all, I have 4 terms. Second of all, I'm looking for a greatest common factor. They are not all divisible by the same number. They do not all share the same variable. So I'm going to throw it in a box. Put my terms in there with their signs. And then I'm going to start looking at my groups. 12 and 15 are both divisible by 3. They also both share a y. There's a negative here. I'm going to pull that out. They're both divisible by 7. They do not both have an x. 12 and negative 28 are both divisible by 4. They both have an x. And then this has a negative, so I'm going to pull that out. Both divisible by 5. They do not both have a y. Now, if at this point you are unsure of your answer, a really good habit is to check your multiplication. So let's multiply 3y and 4x. Do they multiply to 12xy? Yes. Then 4x and negative 7. Do they multiply to negative 28x? Yes. And then check this. 3y and negative 5, we're good. Negative 5 and negative 7, we're good. So let's pretend that I forgot to pull out a negative here. We'll just pretend. The reason why checking your answer is so important is because let's say I forgot the negative and I go check my solution and I'm like 3y times 5. Oh no, it's supposed to be negative. Then that's an indicator that you did something wrong. You need to first of all check that you wrote down the correct numbers in the box, which I did, and then you need to check what you pulled out. And oh, that's it, I forgot my negative. It's kind of a troubleshooting thing. And then just check all your boxes, make sure they all work, and write your factored answer. And you can change the order on that if you want to. So that is all for greatest common factor and factor by grouping. I hope you enjoyed it. If you have any questions, please let me know. I would be more than happy to answer, and I will see you in the next one.